Hello everyone, and welcome. Welcome to the 2013 Connections competition, and good luck to all the teams. My name is Roxy Hamilton, and I'm Talent Program Manager at OCE. I'm based in Ottawa. And I wanted to tell you a little bit about OCE, introduce our judges, and then get on with the competition. So, OCE is about economic sustainability and prosperity for the province of Ontario. And we do this largely by investing in talent programs for at the graduate and undergraduate level in Ontario. And part of that those programs is always industrial collaboration. So the Connections program is all about undergraduates in their final year working with industry to solve a problem for the company and to develop their network, establish their network, and to develop professional skills that will help them get hired. So it's all about developing talent for their years beyond university or college. This year we had over 3,500 students funded by OCE in graduate and undergraduate programs, and over 600 of those students were invested in by OCE. So the best of those 600 students here are here today in various competitions, and one of those competitions is the Connections competition. So welcome. This competition is divided into 3 categories. We have, I'll do them in the order that they will be presented. We have the college category, the OPA, which is the Ontario Power Authority and a partner of OCE and Connections, and the university category. There are 5 teams in each category, except for the OPA category. We had one team that had to drop out. So one team in each category will be awarded the winner, and we only have one winner per category, and the winning prize is $2,000. So that's a nice prize, and hopefully you'll be able to divide it up amongst your teams. The presentations will be evaluated on things like collaboration. Collaboration with industry is very important in this competition. The professional skills that the students demonstrate in their project, as well as the communication skills they've developed. So it's very much about developing the skills that are going to make them useful in their next life. The timing is each presentation should be no more than 5 minutes. It could be between 3 and 5 minutes. You will be cut off if your presentation goes beyond 5 minutes. I'm sorry about that, but we have a very tight schedule. There will be 2 minutes for Q&A by the judges, and then we'll give the judges a couple of minutes to just evaluate on paper your presentations. So that's all I have to say about the competition. I would like you to know who's on our judging panel today. So I'll tell you a little bit about them, and then we can move on to the presentations. First, we have Brian Armstrong, who joined us last year. He's back this year, and Mr. Armstrong recently retired from his role as Executive Vice President and General Counsel for Bruce Power, Canada's only private sector nuclear generator. At Bruce Power, he has been responsible for building and managing the Bruce Power Law Division for the company's corporate secretarial function. He is also Vice Chair and Secretary for the Board of Directors of Ontario Centres of Excellence. Thanks, Brian, for coming back with us this year. Our next judge is Lucy Keating. Some of you may know Lucy from doing professional courses for OCE over the years. Lucy is co-founder and partner of Comexis Inc. Lucy has designed and delivered many education programs for organizations across North America. With extensive experience in project management and coordinating multidisciplinary teams, she also has extensive practice in the communication of complex environmental and scientific issues. And thank you, Lucy, for coming back year after year. I should make a note that Lucy will be in the Career Corner tomorrow, and she will be offering help with interview skills. So I'm hoping that each and every one of you can take advantage of that. It is a rare opportunity. Next is Jenny Millinen, Manager of Funds, Market Transformation and Conservation Division at the Ontario Power Authority. The Ontario Power Authority has been a partner of OCE's and Connections for a couple of years. Jenny is responsible for developing a portfolio of projects designed to test the next generation of conservation and demand management technologies. The projects aim to transform the market, taking us towards a culture of conservation and to help Ontario reach its ambitious electricity targets. Thank you again for coming back, Jenny. Our final judge is new to Connections, and she's Caroline Summers, co-CEO of the Cassidy Bay Group. Caroline has over 25 years of experience in the high-tech industry, both as a company co-founder and senior executive, and has worked as an executive coach since 2006. At the Cassidy Bay Group, she assists organizations to be more effective by building powerful teams and coaches executives to be successful managers and leaders. Caroline is also an active angel investor. She also serves as a managing partner of the Band of Scoundrels, a partnership of angel investors, and a director chairman on the recently founded Capital Angel Network. Welcome, Caroline. Thanks for joining us. Okay, now let's move on to our first presenter. I'd like to call up to the stage PC Cooling, presented by, this is the Algonquin team in the college category. And presentation will be by Jason Fulford with his teammate Azamedin Hoke. I hope I pronounced that all right. Gentlemen?
Hello, we are the Ironside PC Cooling team from Algonquin. I'm Jason, this is Azim. Unfortunately, Daniel and Peter couldn't attend today. So our project was to design and prototype more effective liquid cooling PC for high performance computers. The system had to be capable of dissipating 600 watts of heat while maintaining a 60 liter per hour flow rate. We also wanted to keep the design simple to limit machining time while maintaining aesthetics, because enthusiasts are a major demographic and this appeals to them. So we set out to design 7 components and prototype 6 of them. The 7 components are the filter housing, the CPU cooling block, the GPU cooling block, RAM cooling block, MOSFET cooling block, chipset cooling block, and the heat exchanger. The heat exchanger being the only component that was purely design. So what these do is they sit in contact with the components themselves, for example the CPU, and absorb the heat and draw it into that coolant. The coolant then pumps through a filter and removes debris, which inevitably gets into the system through dust or just accumulation through drawing in through the tubing. And it descends from the highest heat producing component to the least. The coolant then goes through the heat exchanger, where the heat is dissipated into the atmosphere and the cycle repeats itself. We broke it down into term 1 and term 2. We originally planned to design and prototype half the components in term 1 and the other half in term 2. Staying true to Murphy's Law, this was not the case, and we had to revise our schedule. Term 1 was now dedicated solely to designing components, and in term 2, our designs from term 1 were being machined while we continued designing. Because of the delay in machining, we decided to seek alternatives, and we had a lot of parts 3D printed, which reduced the amount of machining so we could meet our deadline. Developing each component was essentially the same process. We developed concepts, compared ideas, revised concepts, tested and simulated them, compared those results, and then made final revisions if need be. Fortunately, our costs were very straightforward in the budget, as all the labor was free for machining because it was all done in-house by the toolmaking program. All that was needed to price was the materials for machining, tooling required for machining, hardware for assembling, and the 3D printing costs. We managed to stay within our budget without any sacrifices. Throughout the project, we maintained constant communication with a few groups. We met weekly with our professor for approximately 15 minutes to report progress and any issues we've encountered. We met the toolmaking students weekly for about 30 minutes, sometimes an hour, to discuss drawings and potential revisions that might ease machining processes. We also discussed timelines, what was to be completed and when it was to be completed. We met with our industry partner weekly for 1 to 3 hours. We discussed progress, ideas, revisions, and really everything involved within the project. Afterwards, we would meet amongst ourselves and discuss any ideas or issues we were having with our tasks, and we would assign tasks and deadlines to each other. So the big question, how did everything turn out? Well, we managed to meet the project requirements, and more importantly, we learned a lot of essential skills and sharpened some skills that would be important to industry. We learned about the design process and how important it is to take time in the beginning to save time in the end. We were forced to become effective communicators, having to communicate with multiple different parties. And lastly, we learned the value of organization, in particular file organization. We had approximately 2,700 files that had to be shared with multiple parties, so it was crucial that files were easily found and easily identified. At this point, we would like to thank everyone that aided this project: Algonquin College, Applied Research and Innovation, Ontario Centers of Excellence, our professor Dave Thibodeau, our industry partner with Ironside Engineering, Matthew Strentz, and the tool makers at Algonquin College. Thank you.
Okay, well, now, hello? Okay, questions for the, thank you. We'll have questions from the judges now.
Could you elaborate a little bit on your interaction with your industry partner? Did they provide you with any kind of direction? What was the nature of the interaction?
Yeah, so in the beginning, he provided us with the design process that he was familiar with. It was a little over 100 pages, and then he broke it down for us into a more simpler format that we could utilize more effectively, as our time limit was very short to design so many components.
Was there one single point of contact with the industry partner, or did you meet with a team?
Sorry?
Was there a single point of contact, one individual with your industry partner that you had the interaction with, or was there a team?
No, the whole team would meet with the industry partner every week. So it was all 4 of us, and we'd meet them at the college at the same spot every week.
Hi there. I have a question about the need for this solution. Why was Ironside Engineering interested in this CPU cooling solution to begin with?
So he himself is an engineer, and he works in engineering firms, and oftentimes there's multiple computers and they make a lot of noise running on air cooling. So currently there is products for enthusiasts, and some engineering firms might utilize these as well to cut down on noise and improve performance. And he thought he could make better designs, so he sought out some research from us to assist him with that.
And does he now believe that he'll be more successful in attracting new clients?
His company is still researching phase, so we were essentially the alpha phase of prototyping. He's hoping to take our designs and see if he can improve those, make another prototype, and then potentially see how he can utilize that in market.
Thank you.
Thank you.
Okay, I have a quick question for you. Are you finished or any questions?
Yeah, we're up to the 2-minute.
Okay.
No?
We're finished the question.
We're free to go?
Here we go. Okay, we'll invite George Brown College to make their presentation. Please come up. Just give us a minute while we finish up here.
Hello, hello, hello. Good? Louder? Jeez.
Okay.
Good afternoon, everyone. I'm here to present my OC Connections project. We did the printed circuit board manufacturing disruption management system. We did it for our industry partner, Autoliv Canada. I'm Elliot Carney-Killian. This is my partner, Vasily Gurin and Lan Nguyen. We're from the mechanical engineering design program at George Brown College. So to begin this project, we start out with identifying our strengths as team members, and we split up our tasks based on that. Vasily Gurin was really good with electrical design and programming. Lan was better with hands-on, so we did assembly and troubleshooting of our project. And I myself focused on the 3D modeling and mechanical design aspect of the project. So just a little bit about our industry partner. Our industry partner was, our industry contact was Mike Lowe. He's a manufacturing engineer at Autoliv. Autoliv produces printed circuit boards. They are used in diagnostic equipment for automobiles that trigger airbags in automobiles. It's a quite big company. It's international. They have 36 major automotive customers. They're in 29 different countries, and they have a strong focus on safety and reliability in their products. So the problem, Autoliv was having an issue with their manufacturing process where they were having delays at their placement machine. I'll just explain a little bit about how these printed circuit boards are created so you guys can understand what the problem they encountered was. So they smear print screen soldering paste onto these boards, and then they move into a placement machine which places the chips on these boards. After that, they have to move into the reflow oven, but there's only a certain amount of time that these can be left out in the air before they move to the reflow oven. The issue that they have is the placement machine would go down, there'd be a malfunction in the placement machine, or they'd run out of chips, and they'd have these boards sitting around. They didn't have a storage unit for them. So the problem this created is they have boards out in the open air. They don't know how long they've been sitting out in the open. They don't know whether people have nudged them so that they're considered invalid or have to be tossed. So the majority of the time these chips were tossed away just to ensure reliability of their products. So we met with Mike Lowe, and he determined the requirements and the scope of our project. He wanted at least 10 printed circuit boards to sit in this unit. He wanted the whole unit to log all the events that occurred in the project, a barcode reader, a physical gate to stop employees inserting the boards without scanning them. Everything had to be grounded in the unit because we were dealing with electronics. There had to be proper keep away so chips didn't get nudged. There had to be an LCD screen that displayed when the board was inserted, when it had to be withdrawn, and the time remaining, as well as the serial number. And we had to utilize Raspberry Pi embedded electronics. So our methodology. We started with problem identification, the brainstorming stage. Then we moved on to our electrical and mechanical design of our product. And then we moved on to prototyping, testing, doing mock-ups to make sure our tolerances were correct. And then we moved on to assembly, and then in the future we'll be doing site testing with Autoliv. So the brainstorming phase. We met with our industry partners several times to define the scope of our project. We had group meetings weekly and storyboard real scenarios within the Autoliv manufacturing environment. We came with 10 concepts. We selected one final design with our industry partner. This is our locking mechanism for our storage unit. It's modular, so it's easily repaired. This is from conception to 3D modeling to the prototype. This is our overall assembly. Challenges we faced was integrating the mechanical and electrical components. There's a lot of troubleshooting involved. And then we had issues with our optical sensor. We had to do some programming variations to fix that, and our latch design. We had a lot of variations on our latch design. So our results, we produced a fully functioning prototype that exceeded our industry partners' expectations. With this added benefit, it increases reliability of Autoliv to produce reliable products, and this will be used within the Markham production facility.
Thank you, Elliot. Sorry, that's the rules. So this presentation, I didn't introduce them properly earlier, but it's Elliot Carney Killian with his teammates Lang Nguyen and Vasily Gurin. Thank you, gentlemen.
Okay, I have to know, what's Raspberry Pi?
Okay, so Raspberry Pi is the single board computer. That's one of the version of embedded hardware you can use. So basically the small chip implements all the things the regular computer does. It's small and easy in power consumption.
Fair enough. Should I have known that before?
You know now?
It's not cocktail talk. That's right, I just wanted to know if you knew.
Just a quick question. How did you guys work effectively together? How did you get the most out of your team?
I feel a really important part of making our team work effectively together was finding our strengths and weaknesses, and then having someone head the electrical and programming. Vasily headed that. I headed mechanical. Landed more assembly, troubleshooting, part sourcing, and like we helped each other with our weaknesses, and like we focused on our strengths as a group, and then we came together to build, as far as I'm concerned, an amazing product that hopefully Autoliv will continue to use and make new versions of in the future.
Any other questions? Sure.
They obviously gave you quite a bit of information, quite a bit of parameter information, but they don't seem to have told you how to build this. Was that your imagination that said, well, here's all the things you need and here's what it's going to look like, came from your head? Is that correct?
Yeah, we went through, like I said, about 10 designs. We had circular storage units, we had vertical ones, we had horizontal ones. We, as a group, we had our program coordinator and us and our industry partner all in one room, and we kind of hashed out ideas. We met with him for a final time to decide on the final design, but we came up with a lot of different prototypes.
Lots of iterations.
Yeah, and concepts. Yeah.
Okay,
Thank you. Okay, we'll go with Team Seneca College. Please take the stand. And we'll have a presentation by Andrew Kubir with teammates Andrea Gonzalez and Alexei Proskurin. They're partnered with Multisolve.
Just as an FYI, Alexei couldn't be here, so that's Hantal Duong. She doesn't look like an Alexei. Do you? No. Alrighty, so my name is Andrew, and I'm presenting on behalf of Seneca College and half of my group in regards to biodiesel as an asphalt release agent. We did our design for a company called Multisolve. They are a chemical company located in the Greater Toronto area. And the idea behind this project was to avoid the use of diesel as an asphalt release agent from the back of trucks. Multisolve was under the direction of Dr. Roger Cook. However, our direct contact was President and CEO Paul Holroyd. Alrighty, so the problem with asphalt as a diesel release agent is that not only is it a safety and health concern, but as the diesel is sprayed on the inside of the truck and the asphalt's released, it leaches into the environment where the asphalt's being laid. The Ministry of Transportation of Ontario has also deemed it as a safety concern, as in the mid-2006 there was an accident whereby a technician was clearing the back of an asphalt truck, and because the remnants of diesel were still there, the shovel arced against the back of the truck and created ignition. The solution that we were solving, or the solution that we had decided, was using biodegradable organic materials. However, the challenge with this is that most biodegradable materials will freeze in sub-zero temperatures, and the performance of the biodiesel hadn't been proven before our testing. So the client's needs from this point was to determine the properties of the biodiesel and whether or not it was of the same capabilities that diesel had. We analyzed the physical properties and compared 6 different samples to determine which of the 6 samples were best as a release agent for asphalt. During our time doing these studies, we kept in direct contact with our professor, as well as Paul Holleroy. The client attended quite a few meetings. We did weekly meetings, about 2 hours long. It had been determined during the first 3 meetings that the following criteria needed to be found: the freezing point, density, the solubility in water, viscosity, lubricity, and flash point of the biodiesel. During the project planning, we had to look into ASTM procedures, the testing and the required apparatus. And because the construction season started in May and we received this project in January, the turnaround time had to be quick. During the freezing point test, we found that the workability of the fluid in cold weather froze at -5. However, we found later that 2 of the samples would not be acceptable for winter conditions. The solubility in water we used to gauge the impact in the environment. And for each sample, the solubility was much lower than diesel fuel, which was our main focus, was to keep the environment clean. The density, which is a key factor for the workability of the material, and we found the density ranges between 0.86 and 0.96 grams per milliliter. Viscosity was used to ensure that the layer of biodegradable material on the bed of the truck would be thick enough and on the rollers of the tires that no asphalt would stick. 2 samples were identical to diesel. However, 2 of the other samples had a slightly higher viscosity, which meant they would leave a more thick permanent layer in the truck, which means less biodegradable material had to be used. Flashpoint was used to determine the fumes and how much of the fumes would ignite, and the sample proved that the flashpoint was higher in diesel fuel. Lubricity, the important one, was the angle of slip required in the asphalt truck. So depending on the viscosity, the lubricity would show at what angle the truck would need to be lifted before the material would begin to slide. Our results were sent to Multisolve, and although there were no standard operating procedures in place prior to doing this experiment, we were able to keep and record our standard operating procedures and apply them to further testing. As it stands now, the sales of biodegradable lubricant has gone up 25% in the last year. Multisolve has also considered patenting their biodegradable material. And like I said, new standard testing and SOPs were created by Seneca College.
Thank you.
No problem. I had 7 seconds. I've gotten a lot done.
Questions?
What did you learn most from this project? Here's your biggest.
Wow. I learned the most from this project. Building ASTM apparatus from scratch is a lot harder when you have to follow procedure. We had a problem with shipping, so we couldn't get a lot of the equipment that we required. So we spent days in design trying to match ASTM procedure equipment.
What were the functions of the various team members and how did you work together?
My job, we split the testing between the members. So, Andrea, you can.
I took care of the freezing point and the solubility of the testing. A lot of it was pretty much not homemade, but we had to make up our own apparatus, like Andrew explained.
My job was to research ASTM material and build the apparatus for lubricity and to determine what or how we were going to provide the apparatus for flashpoint. And Alexi was a lot of planning and procedure. He kept us on target. Sorry, Alex.
And how did you determine who would take on those roles?
It wasn't determined in any specific way other than voluntarily. I knew that I was good in AutoCAD and design, so I took on lubricity, being able to design and create ASTM equipment. So it was kind of a random choice. As it was coming, we would say, okay, these are our two, and then one person would leave the room, and the next person would come in, oh, yeah, those are mine, and that was how we decided.
What would your customers say is the most important thing?
Keeping their employees safe. That was the biggest thing. I read earlier, before doing this test or these experiments, that the gentleman in Ontario who was burned suffered third-degree burns on 78% of his body, and it was actually Ministry of Transportation Ontario that said until there was another lubricant found that they weren't allowed to use anything inside the back of asphalt trucks, and this spread all the way to California, who have now completely omitted the use of diesel. So biodiesel is not only a new technology, but it will spread across Canada for all engineering purpose.
Thank you, Seneca.
Brutal.
That's really good, yeah. Okay, we'll have Mohawk College. Take the stand, please. Take the stand. Take the stand. Okay, today we have Andrew Heaton presenting with his teammates Troy Larkin, Jacob Sherman, and Justin Tiffany. They're partnered with Tiffany Metal Castings Limited.
Okay, good afternoon, everybody. First off, I'd just like to thank OCE and the Government of Ontario for putting this whole conference on. As well, I'd like to thank our judges for donating their time, and as well as Mohawk College and for all of you coming out. My name's Troy Larkin. This is Justin Tiffany, Andrew Hedden, and Jacob Sherman. And this is our lean manufacturing project on Tiffany Metal Casting. So what is Tiffany Metal Casting? Tiffany Metal Casting is a sand casting foundry that specializes in gray and ductile irons. Originally, the business started here in Toronto, Ontario in 1989, where John Tiffany founded the company. But due to a lack of plant space, it was moved to Orangeville, Ontario in April of 1994. So what our team did, going into Tiffany Metal Casting, our objective was to find any bottlenecks, as well as any wasted space in the factory. Once found, our goal was to come up with solutions that the problems faced by the company, as well as ultimately lean out their process. So going through the factory, the main bottleneck that we found was in their molding department. TMC had way too many orders piling up on their Hunter 3032 line, so improvements needed to be made to the process so that more shipments could be shipped out on time. In their green sand molding department, Tiffany Metal Casting has 3 automated molding lines, the biggest being their Hunter 3032. The way the current machine is designed, the company can only pump out 20 molds per every 2 hours because of cool down times. So you have to wait for the molds to cool down before you can shake them out and take them out. This presents a large bottleneck in the company, seeing as they can only produce 80 molds a day on this one machine. And that's just a picture of it there. That's their one Hunter 3032 line. So currently, Tiffany Metal Casting buys their scrap metal for 80 cents per pound. As well, they have a molding cost of $25 per mold they create. And this is just an example of a Duragear 225 worm housing, and it weighs 154 pounds. So to make one casting for this Duragear, it costs TMC $148.20 per one casting, and so per day it costs them around $12,000. So Tiffany Metal Casting charges their clients $1.50 for their metal, as well they offset their molding cost by $25. So they charge their clients $256 per casting. At $80 a mold, this generates a revenue of roughly $20,000 per day on their old Hunter 3032. So the new design we came up with is we worked extensively with Mark Tiffany, the CEO of the company. We had many sit-downs with him and went to many meetings with them, and we came up with a new design for the machine to eliminate this bottleneck. This machine would be a linear model, as it is now, or the one before was a carousel model, This one contains 3 rows and 2 levels. And it can hold up to 99 molds, whereas the old one only carried 20 molds. So as you can see, rather than being a circular carousel model, it's a linear model, and like I said, it has 2 levels and 3 rows. How it works is it's poured at the top there, and as the molds work down, they cool, and it drops to the second level, and it works its way back up. So as you're pouring molds, you're also shaking them out, so there's no wasted time waiting for molds to cool down. So it's just a continuous flow as it moves along. So the new machine will, on average, average 50 molds per hour. That's already more than double the old machine produced in 1 day. We do that in 1 hour. There will be, like I said, a continuous flow, so molds will be poured as well as be shaken out at the same time. And this will generate, on average, 400 molds per day, which will generate a gross revenue of approximately $102,000 compared to the old $20,000, which is just a huge difference. Just to touch on that again, like I said, the old Hunter 3032, as you can see, only generates 80 molds per day. This new one we created does 400. That's 5 times the molds you're producing per day, and as well, the gross revenue goes from $20,000 to $102,000. So I mean, that's huge for the company. Not only does this generate a substantially greater amount of money, it also completely eliminates the bottleneck that we were faced with at the start, and provides for a continuous flow. So our objective as a team was to go into Tiffany Metal Casting and eliminate their biggest bottleneck and their waste of space. We applied our lean thinking, and our team worked together with the company to provide a continuous flow to solve their bottleneck issue. As well, we went in there and we also came up with a couple different ideas. We added different wheel abraders, we moved power packs, we got a second furnace running, and we just didn't have time to touch on that in our presentation. So we did that. I'd just like to thank everybody again, and that's our presentation.
Thank you, Mohawk. Questions?
Did they build the new machine?
Yes, it is. It's up and ready to fire up, so it's good to go. They liked it, so they started it right when we decided on the final design. They were very happy with it, so they went in and they started building it, and it's ready to go now.
If I could add to that, actually, a lot of the solutions that we came up with their problems, obviously in our 5-minute presentation, we can only focus on the main one, but we came up with another great solution for inventory, their tooling. Basically took all the wasted space out of the company, went and streamlined it 100%, and they really went ahead and implemented it, and they went really nuts with this stuff. So it worked out really good for Mohawk and for the company as well.
So do you guys all have jobs with them now?
Not yet, no.
No.
A serious question. How did you divvy up all the work? How did you decide on what your team would do?
It was really everybody kind of worked together. Actually, there wasn't really any. I know a lot of these other presenters had set jobs for each thing. We really all worked together. We all went in and did process flow maps together. Really went in and got to know the company. Like Troy said, sat down with Mark and Gord, who's the vice president, and really went over some designs and prototypes. A couple carousel designs as they had, but then we ultimately settled on this linear model. They're really going to benefit this company, as you can see by the cost difference that we showed in our presentation.
I'm curious about the linear solution. Is this something that they hadn't thought of before?
No. So
typically mold is a traditional carousel.
Yes.
They just hadn't thought about going to a linear solution.
So
before?
previously, in this company, all of the Hunter lines, we did a little bit of research with the molding company too, and all the Hunter lines that this company has they're all carousel. So this linear thing is really very innovative to this company. It's going to allow for a continuous flow. The molds, they don't have to wait to be shaken out. So again, this is going to work great for them.
And did you work with the company to identify those bottlenecks, or were they identified?
Absolutely,
for you?
yeah. We sat down, like Troy said, we sat down extensively and did walkthroughs with Mark and Gord, and how many times we sat? Probably at least 10, but we had many sit downs with them.
Thank you.
Thank you.
Mo? The last time, the last team in the college category is St. Lawrence College. Can the team please take the stage? Presenting today, I believe, is Jason. Is that correct?
You got it.
Jason Arnold, and he's accompanied by Brian Fryer. They were partnered with Aztec Associates, Inc.
Thank you. Okay. Thank you for that introduction, and good afternoon. My name is Jason Arnold, and this is my colleague Brian Fryer. We're both graduates of the Energy Systems Engineering Technology program at St. Lawrence College, and we're here today to present to you about the recently launched solar e-bike charging station at St. Lawrence College. So this project actually began as a partnership, this project began as an idea that Brian and I had at the end of last summer, and because it began as an idea that we actually had to find industry partners and funding to make the project go forward. And so over the course of the past 10 months, it's been an exciting opportunity for us to engage partners from several industries and who've had impacts beyond the campus. Now, as Energy Systems Engineering Technician students, we focus on renewable energy technologies. Now, finding a way to pair it with sustainable transportation such as e-bikes is a fantastic opportunity. On the SLC on the SLC Kingston campus, we have Energy House, which is a renewables technology demonstration building. It's an off-grid building which is powered by 4 kilowatts of solar photovoltaic panels, as well as storage batteries up to 30 kilowatt hours of capacity. Now, with this abundant supply of renewable electricity, it's an ideal setting for our project, which was the solar e-bike charging station. So the additions that we made with this to the facility with our project were covered parking and charging outlets for up to 8 e-bikes, as well as monitoring equipment that would allow us to data log and track the demand and usage of the facility. Now, with the design, after we had come up with the initial design that you just saw, we proceeded with the feasibility test. Energy House, the facility, is a classroom and lab. And so to make sure that the existing facility could handle the load that we were going to add to it, we performed this feasibility test here. And what you're looking at is the graph that shows the available energy in blue, as well as the predicted demand in red. And as you can see here, the red is kind of an extreme case scenario under maximum usage, and we have a near ideal match. Now, the second object that we worked on in our design was a roof structure for the building, and as you can see here, the design of a roof structure, it would seem straightforward enough, but as we learned during the procedure, building permits have a way of surprising you, and so we'll have more on that in a moment. Talking now about our industry collaboration, as you had mentioned, our primary partner in this project was Aztec Associates Incorporated. They're a locally based Kingston company who specialize in smart meters and GPS tracking technology. Now, in addition to a cash contribution, the company president, Jeff Salter, enthusiastically committed a meter, a smart meter that is, and offered to repurpose one of their in-home displays for us. Their monitoring technology would allow us to collect research data to assist in planning the future expansion of e-bike charging stations, and in turn, our project would provide them with a test bed and real live world data onto a prospective new market. Now, because of the broad appeal of our project, we continued seeking funding and industry partners after Aztec, and we began on campus and then proceeded out into the community. As in total, we approached 5 partners on this project, and all of them joined us and were very enthusiastic to get on board with what we were proposing. By the end of the month, we had reached 300% of our original funding goal, and over the course of the 10-month project, we had managed to engage 9 industry partners on a frequent basis. Now, to talk a little bit about the project planning and management aspect, from concept to operation, as I had said, it took us 10 months. However, as energy systems technology students, the project management presented challenges. As you can see, it was our lengthiest phase. Initially, a lesson in patience. The permit process did take us months, but fortunately we were able to leverage access to some of our resources on campus and get our building permit. Talking now quickly about the build, Because the build was such a collaborative effort, it spanned most of the month of April, but we were able to overcome minor challenges and by simple perseverance and planning contingencies as well as engaging our partners, we were able to build it as planned and on schedule. In parallel with the build, we were involved with business and marketing partners to plan a launch event, which coincided with the Sustainable Energy Symposium at St. Lawrence College. Now, in addition to local coverage in the newspaper and TV, we were also featured provincially on the CBC, which provided valuable publicity to the college as well as our industry partners. Now, quickly about to our outcomes. At the college level...
Thank you, St. Lawrence.
Okay.
No. We'll have questions now.
Yeah, you guys talk about those, hopefully. Okay.
So I'm curious to know, to what extent did you evolve your designs and your solution based on the input that you were getting from your industry partners, your clients?
The design was pretty straightforward. We did most of that. Their contribution was more at this point into helping us do the data logging and the monitoring of the station. And then the future of that is getting some e-bikes owned by the college and then instrumenting those with their next generation asset tracking devices, which can do more than just GPS tracking, but also monitor the voltage in the batteries, how many kilometers it's traveled, and other various points of interest.
So help me understand what Aztec is going to do with this.
Well, with the asset tracking devices that we can put in the e-bikes, it's a proof of concept for them. We never, unfortunately, got to that aspect of our presentation. So currently, they have these devices which are just for asset tracking, but they want to add more capability to the devices, so it would be helping them further develop that product.
How did you select your partner?
Sorry?
How did you select your industry partner?
We were connected with our industry partner through the Sustainable Energy Applied Research Center, and they were a good fit with us. They were someone who had already been involved with the college. They've taken on several students for internship positions, and they had the technology and the abilities that we needed to do what we needed to do for the project.
And what was the biggest impact for them, or for all your partners? Because you worked with a few.
Well, the biggest impact for them would be opening up a new market for their in-home display that they use. So they're able to now take that product and apply that to a broader market, as well as in the future we're going to be helping them develop the asset tracking devices.
Thank you, St. Lawrence.
Thank you.
We're now going to move to the Ontario Power Authority, or OPA, category. These projects are about energy conservation and electricity. And we will start with Queen's University. And we'll bring up Matt Davies and John Slaughter, please. Their industry partner was Scott Environmental.
All right, well, good afternoon.
Okay.
So 9 months ago, the CEO of Scott Environmental Group approached us with an idea to create biofuel from construction and demolition waste and shingles. So this is a physical fuel that's made up of a chip of both shingles and wood. When George Scott, the CEO, first approached us, there was a certain criteria that our process had to meet. Firstly, it had to be very compact so it could fit on their existing property. It was also a pilot project to prove to the community that this could be done in a safe and sustainable way. By a live loading process, we mean that waste comes in, fuel comes out, with no storage in between. We're given an initial budget of $500,000. So right off the bat, we spent a huge amount of time talking to suppliers, trying to get that background knowledge we needed in order to make educated decisions on what equipment was appropriate for our process. So shown here there's a horizontal shredder and a wood hammer mill that's used to process the wood side of the waste. And then there's a shingle hammer mill and a gyratory screener used to process the shingles. Initially, we wanted to process all of it. So we had 2x4s, pallets, shingles coming in. But about midway through the project, we had a big scope change where we decided to have the inputs to be pre-ground wood, so a 2-inch grind of wood, and once again, whole asphalt shingles. This decision was made because Scott Environmental Group currently owns a portable, large-scale shredder that they can bring to construction sites and transfer stations, grind the material there, and then it is delivered to our process. This makes a lot of sense for transportation. You can fit more per trailer, and you also makes it a lot easier for us to handle because it's already partially processed. So over the project, we created a lot of layouts. These are just some of the many we presented to our client. Every 2 weeks, we met with George, and it was pretty commonplace for us to present anywhere from 2 to 4 of these layouts. So it was definitely an iterative process. We would present the layout, discuss it with him, and then 2 weeks later, we'd come back with a new set. George is a psychology major from Queens, but he's definitely an engineer at heart. So about 6 months into the project, it brings us to the layout on the bottom right. So this is our final rough layout. And things got really, really exciting for us at this point because the project went live. George decided that we were going to go with it. Down payments were made on all the equipment, and at our recommendation, an external engineering firm by the name of Grant Aggregate was brought on board to work with us to finalize the design. We were also working very closely with many of the suppliers, specifically Shooty Buffalo Hammer Mill, and a lot of the equipment required a lot of custom design, so we had to spend a lot of time with them, as well as working with the City of Kingston and the fire department to ensure that our process met all safety and regulatory standards. So, ta-da, there's our finalized layout. I'm not going to have too much time to go into it, but this is the final CAD layout that we created through collaborating with Grant Aggregate. Quick financial overview. As you can see, we weren't even close to being under budget, but what you can see is that there is a very strong business case. Because right now, all of Kingston's waste is trucked to Ottawa at a cost of $98 per ton. And our break-even calculation is $60 a ton. So we have this $38 of room to work with. And the benefits don't stop there. So in the first year, operating at 40 tons a day, about 15,000 tons of waste will be diverted from from Ottawa landfills, which corresponds to 5,000 tons of petroleum coke not being burned in cement kilns, and also an 80% reduction in CO2 emissions. And it doesn't have to stop at Lafarge, and the plan is not to stop. So this fuel is to be burned initially in a cement kiln, but it's a fuel that could be used in other cement kilns, and in the next 3 years, we plan to expand to 100 tons a day, where this fuel could be used in cogens and power generation stations as well. This was a great learning experience for us, and something that's exciting is down in June, we're going down to pull the switch. It happened, and it's done. So thanks for your time, and I'm just going to take a moment to acknowledge everyone that helped us out. So thank you.
Thanks, Queen. Questions for the team?
What's the future plans of this? Are you involved with that?
So as of now, no. We sort of passed everything over to Grant Aggregate. So when we brought them on board, we brought them up to speed, and we worked with them to finalize the design. But at this point, the implementation is on them. So it's we're not directly involved, but George has given us the honor of going down to cut the ribbon. But yeah, that's our extent.
What's the market for the fuel that you've produced?
So currently, Scott Environmental has a contract with Lafarge in Bath, Ontario, and this is for 40 tons a day. And in 3 years, that contract is planned to expand to 75 tons a day. So that almost fits our whole quota right there. Our process is designed for 100 tons a day, so, and this fuel could also be burned. It just needs to be burned in a high temperature fire, so cogen or power generation also.
Could you just maybe quickly talk about how you divided the roles on your two-person team to accomplish this?
Okay, so we were actually 3. Laura couldn't make it, unfortunately, but yeah, it was. It's hard to say. Like, we weren't set in our roles. Like, one person was. We definitely collaborated a lot, but it was definitely. I guess for the strategy would be divide and conquer. So. But we all covered all areas. I was more focused on layouts and the more macroscopic orientation of equipment.
Wow.
John here did a lot of work with the drying of the material and also the dust collection for safety. And Laura was involved a lot with some of the other more specialized equipment and with the fire safety. Yeah.
Thank you. Okay, we'll have the next team now. Algonquin College, please. This presentation is by Jared Potvin with Eric Cote and Dan Napper as his teammates. And they're partnered with Hydro One.
Oops. Okay, so I can begin?
Yes.
Okay. So, hi, I'm Jared Poppin, and this is Eric Cote. Unfortunately, Dan Napper and Ryan Devlin couldn't be with us today. The technical coordinator for our project and Hydro One liaison is Alex Yang. So Hydro One is preparing the grid for wide-scale adoption of electric vehicles. They're also seeking intelligent upgrades to the grid to accommodate the additional load and minimize power quality issues. HARK was created, which stands for the Hydro One Applied Research Consortium. It is a 4-year project, and we are currently in year 2 of 4. It composes of 4 different colleges, Mohawk, Northern, Georgian, and Algonquin. The first year of the project was primarily research, and our year, the second, was primarily design of the lab that we were going to use. Our first few meetings with our industry liaison were to discuss the project objectives. We determined that we needed to quantify the effect of electric vehicles on the grid and power quality, develop guidelines and recommendations for installing electric chargers, create lab equipment to simulate a household and to record that data, and to also research smart home infrastructure as a means of remote monitoring and control. This is the wall that we ended up creating to simulate the household and the electric charger. National Instruments equipment was used for the data capturing. Our project was funded generously by OCE and OPA with $3,500, and Hydro One also donated $5,500. Here you have a price breakdown of our major expenses, and as you can see, we completed the project just under budget. Here's an example of the Gantt chart that we used for our project. It's an excellent tool for time management and an incredibly great aid for our planning of the project. During the first half of the year, we weren't using the Gantt chart as much as we should have, and essentially not a lot got done, and that was a problem that we addressed and made changes to it. As you can see, we also spent the first half of the year researching a lot to do with the project. We had weekly meetings with our industry liaison, Alexander Yang, and we also had teleconference calls with Northern to discuss the remote access, which they were working on. In November, all the consortium members visited Mohawk College to have a meeting, basically a day long of meetings and just group collaboration and brainstorming ideas. A discussion board was also created for the HARK partner colleges, and it was an excellent way to pose questions to the other partners and also a valuable a tool for collaboration and file exchange. Some of the direct benefits to our industry partner were a reduction in unplanned outages, reduction in costs, improved power quality and reliability, and improved stability of the grid. Teamwork, especially in this project, was extremely valuable. The scope of the project, one person couldn't do everything, so we had to determine early on each other's weaknesses and utilize those strengths and weaknesses to our benefit. At the top picture is our group picture. You'd like me to stop?
No, one more minute.
Okay. The top picture is the picture of our group at the Applied Research Day. At the right, you see Eric wiring up the back panel of the wall. Down below, you see us selecting the wood that we were using to build the wall. The middle one is the unfinished wall, and the final picture is the completed wall. I'd like to take this time to thank all of you who are here to listen to us today. I'd also like to thank all those who helped make this project possible, the Ontario Centres of Excellence, the OPA, Hydro One, and Alexander Yang and Algonquin College, and everyone involved in the Applied Research Office. Thank you.
Thank you. Questions?
Have Hydro One decided what they're going to do with the wall that you guys built?
Well, essentially, we're only in year 2 of a 4-year project, so year 3 is more of the data collecting. So when they do, the new students that'll come on and take on this project, they will do basically all the different combinations of data collecting with a charger in combination with your house washer or oven or any other number of those. And so they will look at our data and hopefully utilize that in the future.
What's the most important thing that you learned about collaborating with other groups?
That sometimes it's very difficult to get information out from the other groups unless you're really pushing at the other groups to give you that data and help you out. That would probably be the major problem.
What would you do differently if you were to start it now?
Start everything a lot sooner, because a problem that we ran out into was the delay in receiving components that you order. Our current transducers that we used were from a Canadian company, and we chose them because of the quicker delay the quicker delivery time that we would get. The current transformers that we would have liked to have used were going to take 6 weeks to arrive, and they were from the States, so we couldn't use those, unfortunately.
Thank you, Algonquin.
Thank you.
Let's have the McMaster team come to the stage, please. That's Mohammed Azari with teammates Mohammed Hussein, Amaruddin Abdul Hadi, and Amrul Ishaq. I hope I said your names okay. They are partnered with MCAH, and you'll have to explain what MCAH stands for, please. Pardon?
There are 2 different McMaster teams.
Yes.
And so this is the presentation for the OPA.
Yes. Yes.
The team that you just listed off was.
No, this is OPA.
Yeah.
But these are not the OPA students.
They could present this presentation, but it wouldn't be as good as what we
No, this is.
No, we want the OPA.
I need the MCAH team.
Okay, so that's us.
Yes. Yes.
I just wanted to drop off a copy of what we presented and paper just for you guys to scan.
Oh, okay. Thank you very much. Pass that to the judges.
So innovative. Excellence. Thank you.
Anytime.
Okay. So my name is Simon Edwards, and I'm going to be presenting today. Basically,
our entry, McMaster University's entry into the 2012 Mechanical Contractors Association of America student competition. And again, the MCAH is just the Hamilton coagulate of that. So to the next, oh, there you go, thank you. So for the competition, basically what it was is we were provided with NASA's 50,000 square foot space exploration center in Cape Canaveral, Florida. And they asked all the different competition teams to respond to an RFP and prepare a proposal for this project that included the cost and scheduling of the full plumbing and the HVAC system, as well as the service and maintenance. And they asked us to include some value engineering suggestions that maintain the LEED Platinum status of this building. Now, in reality, what it really took for us to complete this project was an immense amount of time sitting with different contractors and engineers around Hamilton and drawing upon their experiences and adding that to what we've learned in the textbooks. We had to develop a company, and we had to present it in a sort of way that we've never learned before in university, where you have to talk about the safety and the security of your company and the project backlog, and it really opened our eyes to the different things behind all that. Then we had to look at these engineering drawings that we hadn't really seen before and start to figure out how to cost and schedule this and develop that technical background. And lastly, not only were we completing this report based on the specifications asked, but we were actually competing with schools from across North America. And that really forced us to take a look at what we could do that they wouldn't even think of. So the final result was that we placed 8th in North America, and there is our award over there. And we developed a huge amount of connections with people from all over the industry, from estimators to presidents and CEOs of the company. And we were actually the only Canadian team to participate this year which really was very impressive for the only Canadian team to finish in the top 10 and really put Ontario on MCAA's radar. So a bit about the technical background. As I mentioned before, we sort of went through the engineering drawings and we came up with how we could cost and schedule this. And we had to really look at the general conditions and see what goes into a general conditions. It really makes you look at all the little details behind a project that you'll never learn in a textbook, which was really an incredible experience for us to draw upon from sitting down with contractors. We went over the service and maintenance, and then as I said before, this was a time for us to really draw upon our theory from university and create some value engineering suggestions and make some calculations on how we could actually increase the energy efficiency of the building and even maybe make some cost saving suggestions to just save the general contractor the cost. So on a more overall scope, we had to look at this massive goal, which took many months of planning, and break it down into smaller milestones, see how we were going to complete this. And so the first objective for us was to divide the team up, and we had a project executive, a project manager, service and maintenance manager, superintendent, and a chief estimator. And using these 5 different titles based on our previous experiences in the field, we were able to set off, and through team communication and work on our own, we were able to meet the objectives bit by bit as we went through our schedule. Now, it was most important to present ourselves as a professional company, as I said before, and really look behind what we have to do there. Things like the litigation component and like I mentioned before, the safety, and these different things that you never think of, and you have to talk to people, the bonding, the financial backlog and past projects, and how does a company present themselves. And really, it was the creative problem solving that led this to come all together and to lead us to think of what we can do that other teams aren't going to do, and how we can be more competitive to the project that we're essentially a company trying to win the bid. For client relations, we had a great opportunity to meet an enormous amount of contractors in Toronto and Hamilton, meeting with them in their offices and coffee shops, as well as traveling to San Antonio, where we received our award and met with many CEOs and VPs and project managers from all over the industry there, an excellent opportunity for us. And lastly, just to go over the noteworthy outcomes one more time, like I said before, we came 8th in North America, which we're very excited about, and it forced us to look into the background of a project and the complexities that go behind it, beyond just the calculations and the overall look of what you see. As a team, we grew together, but also we grew as individuals, and every time we sat down with people from the industry, it really forced us to draw upon their experience that we don't have as students and really see how we can combine their experience with the theory that we've learned in university. And lastly, this was actually at McMaster University's second year placing in the top 10 as the only Canadian school competing in this North American competition.
Thank you, McMaster.
Which once again, thank you very much. Are there any questions, please? That was the last slide.
Sure. I've got a question for you. So you did a lot of networking. What's the one key lesson you've taken away when you need to get that piece of input from a CEO? How do you actually get in their agenda?
Sure, that's an excellent question.
Sorry, can you say that question again?
You needed to meet with CEOs and other companies. These are busy people.
Yeah.
What's the one key trick, lesson, strategy you learned in order to actually get time in their calendar, get their attention?
When we started this competition, we were actually very nervous about interacting with the industry, being students and being unconfident with ourselves. So we progressed on our own as much as we could, and then we waited very long before we interacted with the industry. One thing we didn't know is how outgoing and easy the industry in Hamilton is. So once we started talking to them, they were very generous in sharing their knowledge, actually more than we had thought. So, I mean, if we could go back in time, like I would have started talking to them earlier and trying to take more out of it, would have made our competition less stressful.
How did you leverage your team in all of this?
Several of us had industry experience in the past based on summer jobs and stuff. And so basically, for example, Dan, who had worked in HVAC maintenance prior to us forming as a team, was able to get a better grasp on sort of how he could contribute his industry experience on that. And Marco was more focused on the plumbing. And together with sort of what we took from outside and also from questions that we were asking to the different industry executives, that's how we were able to sort of find our way individually. So I'm not sure if did that answer your question? Okay.
No more questions?
Are there any other questions?
Oh, go ahead. Go ahead. I'll give more time on questions.
Tell me a little bit about when you must have done some post-project analysis, right? And so why did you place 8th?
That's interesting. Actually, when we went to San Antonio, the final 4 teams presented their projects. And so we got to see what they did and compare it to us. And then another thing that they have is they have the general contractor who did, this is a real building in Florida that was built 2 years ago. So the people that actually did this building come and tell us what they did. And so we can compare our ideas. And it was amazing. The first thing that struck me was our final price was $1.6 million. And the variation in teams that said, oh, we think the cost will be $1 million and we think the cost will be $20 million, the variation was just enormous, and the amount of ways that can go into building a project. And I think that for us, there were a couple ways that maybe we could have increased the schedule. There was actually one team I remember had a really interesting thought that because it was a NASA building, heightened security. And they put that in their proposal, which is something that we didn't put in our proposal. And so I think that was really important for us to draw upon not only what we did that other teams didn't do, but also what other teams did that we didn't do and how we can use that further.
Thank you, McMaster.
Thank you so much.
That was Simon Edwards, Daniel Guidoni, and Marco Capobianco. That's a good one. Okay, we'll have Queen's University, please. Emma Simpkin, please take the stand. And she was partnered with Utilities Kingston.
Hello, my name is Emma Simpkin. I was a member of the Do In-Home Displays Lead to Conservation Project at Queen's University in partnership with Utilities Kingston. My team members included Wilson Hung and Zain Shazad, absent today. Did you know that Kingston Hydro has a cumulative electricity savings target of 37 gigawatt hours by 2014? This is equivalent to removing 3,000 homes from the grid. The purpose of our project was to determine if in-home displays could help Kingston residents to reduce their energy consumption to help meet this goal. In-home displays reinforce behavior modification. In order to fully benefit from the energy monitors, people need to understand how they can save energy. We provided our participants with an educational pamphlet for this reason. An in-home display is a device which clips passively to your outdoor smart meter and transmits your energy usage data every 30 seconds to a display unit inside of your home where you can view it. The main questions that our client wanted us to answer were, 1, does the use of an in-home display help users to reduce their overall energy consumption? And 2, do users shift their energy usage to off-peak hours? The study involved 9 Kingston residents who had in-home displays installed and 17 control subjects. The study ran for a total of 2 months between February and March of 2013. Hourly kilowatt-hour data was collected for both the participants and the control group during this time, directly through the Utilities Kingston smart meters. Historical data was also collected for the same time period in 2012 for comparison purposes. We also developed a method for temperature correcting the data. We used a number of tools to keep the project on track. We drafted a 20-page project plan, including a Gantt chart to map our progress, which evolved into our final 140-page report. Our original risk analysis plan involved 12 potential risks. During the project, we encountered and fixed 5 problems arising from those risks. Through the use of contingency funds in our budget, we were able to purchase an additional 4 in-home displays when the client did not have sufficient funds to purchase all of the displays required for the project. The schedule that we developed included 4 weeks of leeway in case of project delays. We experienced delays in receiving units and in installation, but because of the extra time built into the schedule, we finished our project on time. We originally had the work of each group member reviewed by one other group member. As an improvement, we decided to have all group members review all work, but we could have used a checklist. We had a very strong support structure built into our project. First, we had the Queen's University staff, including our course instructor and our industry advisor, who reviewed our work and provided suggestions and guidance. Our main client contact at Utilities Kingston was our resource for clarifying the objectives and scope of the work. We met with him 6 times during the course of the project and were in email or phone contact with him every week to ensure that we remained aligned with the client's needs. The staff at Utilities Kingston also assisted us. There were technicians who installed the in-home displays in participant homes, the legal department which made sure that our agreements with participants were legal, and the marketing department assisted us with our marketing campaign to find volunteers. The project participants provided feedback to us on the in-home displays and their experiences through 3 surveys and via email. The control group and participants generated data that we required. The final results of our project were as follows. When a temperature correction was applied to account for the temperature differences between 2012 and 2013, the participants overall experienced a decrease in energy usage of 10%. Of the participants who reduced their energy usage, they had on average $29 of savings on their utility bills over the course of the study period. There was a 2% decrease in on-peak energy usage and a 4% increase in off-peak energy usage. However, none of these results were statistically significant due to the small sample size. The project had positive outcomes for the students, the study participants, Utilities Kingston, and Ontario. We increased our understanding of the industry and became better aware of sustainability initiatives. The study participants, in most cases, reduced their energy usage and their utility bills. Utilities Kingston has proposed a larger scale study to build on the work done for this project and can use our proven analysis method. Ontario will benefit from this project because the project is aligned with Ontario's energy reduction goals, especially if the project is extended to a larger scale. Thank you for your time, and I will now open the floor to questions.
How did your team all work together?
Sorry?
How did your team all work together? How did you divide up the work between the team?
Okay, so for our team members specifically, Wilson was mostly in charge of being in contact directly with the client, so he was the one who sent emails to the client and who talked to him on the phone. However, everyone had access to what he was saying and input into what he was saying, as well as feedback on all of the emails that were sent. As for Zane, since he was a commerce student, he worked a lot with the budget and with the economic analysis. As we saw here, the $29 of savings came from his work. And I was mostly involved in organizing the project, as well as doing a large majority of the data analysis, along with Wilson, who was also in chemical engineering.
How were the customers that you installed this product or this device in their homes, how were they selected? In a blind random selection, or were they early adopters, or?
Unfortunately, we couldn't do a random selection. Originally, we wanted to put out a large marketing campaign to the Kingston public in general, but our client believed that that would cause some anger among people who weren't selected for the project since it was such a small scale. So in the end, Utilities Kingston decided to pick their people that they thought would be interested internally through the company.
Okay, and did the in-home display highlight what peak hours were for the customer or not? Because one of the things you wanted to find out was, would they load shift, right? So to do that successfully, to understand that from their side of the display, you would have to have been showing them what peak hours were. Is that the case?
Yes, the in-home display gives you a whole bunch of information, including the peak hours, the energy that you're using, the amount of money that you're spending in some cases. As well, we provided them with a pamphlet that gave them specifically the hours that were on peak, off peak, and mid peak for their use.
Thank you.
Okay.
Any other questions? Thank you, Queens. Okay, we'll move now to the university category, and we'll start with Queen's University again. This will be presented by Allison Chong with Lyman Chung and Andrew Mayer, and their partner was Peak Works. Whenever you're ready.
Okay. Good afternoon. My name is Allison Chong, and I, along with my teammates Lyman Chung and Andrew Meyer, worked with Peak Works on the assessment and redesign of the personal lift assist device. North America spent over $90 billion on chronic lower back pain injuries in 1998. That's over $90 billion, and it's projected to increase. Now, this project is exemplary in showcasing the successful collaboration between academia and industry. Dr. Joan Stevenson and her team of doctoral students at Queen's developed PLATT, an on-body lift assist device, as a preventative action against lower back injuries. Peak Works, a small company in Ontario, who has worked with Queen's on many OCE projects in the past, acquired the technology for initial product development. John Levitt, president of Peak Works and our primary contact, recognized that their prototype had good preliminary in situ test results, but would benefit from cyclic testing and possible minor refinements. He came to us for this testing and design work, and based on our results and recommendations, Peak Works is updating the PLATT design in preparation for a market release. PLATT is an on-body lift assist device that aids lower back muscles and promotes proper lifting posture. So the spring pack aids in relieving excess force on the lower back, and this force is redistributed over the shoulders and transmitted to the quadriceps. Both are areas that can safely support increased loads. This highlights our interactions with our client, project supervisors, external services, and internal services. And our first meeting with John included discussing and agreeing upon project goals, priorities, and expectations. And throughout the project, our team prioritized upcoming tasks based on these goals. And at that first meeting, John and our team determined that there were two questions our project needed to answer. Will the PLATT be reliable for its expected life, and will it meet or exceed user expectations? Now, the original PLATT design had 72 permutations of components to customize and fit it to each user for proper ergonomic benefits. One of John's goals was to reduce the number of parts and move towards simple, universal sizing. A simply sized device encourages user acceptance and is attractive for companies as it allows their shift workers to share PLATT units. John's highest priority goal was to learn when and how the spring pack system would fail. Failure of this component could result in a dangerous and sudden release of stored energy. Our team's biggest challenge was getting access to testing equipment. After numerous emails and visits to various Queen's faculty members, we acquired this Instron slated for disposal. We needed to run 3 tests on it, so in addition to our bi-weekly meetings, our team was in constant communication regarding the status of the test in progress to minimize time that the machine was idle. To prepare for the cyclic testing, we restored the machine and developed this testing rig using pulleys to reduce the testing time from 24 days down to 3 days. In this reduction, however, we made a calculation error that was causing an unexpected failure. So we arranged a phone call with John to explain our mistake and how we plan to move forward with the testing. He was understanding and supportive of this learning experience as we were able to draw positive conclusions from it. Once we fixed our error, the spring pack failed 3 times, all at less than 5% of the expected cyclic lifespan. Each time, a wire frayed and broke while running over an internal pulley. So we alerted John and brought up the failures at a weekly meeting with our course supervisors. And John suggested literature on this type of failure, and our project supervisors briefed us on what to look for when analyzing the parts. From the underperformance, it was clear that a significant redesign was required. Based on the literature, increasing the pulley diameter should prevent these premature fatigue failures. And while we were redesigning the spring pack for larger pulleys, we saw an opportunity for innovation in the overall design. So the original spring pack has one spring, sized and permanently installed for the individual user of a particular PLATT unit. Our design increases the pulley diameter and allows users to adjust the stiffness without disassembling the spring pack. It allows one spring pack to fit all users, and it uses off-the-shelf parts, which reduces the cost of the system. Additionally, we made several alterations to the harness system that improves the fit and ease of adjustment for the user. Together with the work done by our team and John and his team at PeakWorks, we have reduced our 72 permutations down to 1. We now have a prototype for a universally sized plaid while maintaining a high degree of customization. Looking back, we have answered our 2 questions. With our increased pulley diameter, we have created a robust design that will meet the expected design life of the system. And with our creative spring pack design, we have helped create a product that is far more valuable for both PeakWorks and the user. Not only that, but the testing that we performed identified weak areas of the plaid that had been previously unconsidered. And if it had gone to market without our testing, there would have been some premature failures while the product was in use. Additionally, our work streamlines the fitting and sizing process and reduces part inventory for PeakWorks. As a result of our work, PeakWorks is making some significant alterations to the plaid design in order to make sure it's reliable for its expected design life. Among this list of thank yous, I'd especially like to thank John Levitt and Joshua Fick from PeakWorks, as well as our project supervisors, David Strong and Trevor Lewis, for their guidance and support, as well as OCE for their financial support. Thank you, and I'd now like to open the floor for questions. Yes. Looks good.
Does your customer anticipate the market for this being primarily construction, or is it hospital workers, or who's the primary marketplace?
It's interesting. When we were doing the preliminary research for the project, they had some field tests and distribution and, assembly line work. But as you do the research, you look, there's such a big market for it. There's anything in distribution and merchandising, anything with heavy lifting, static forward bending, or repetitive static bending. It was incredible how many markets we saw that could use this product, from actual industry to homeowners even, doing gardening work or work around the house, and including construction like you mentioned.
Nurses.
Other questions?
What did you learn from this project?
There was a lot of things that we learned. Mainly was the professional skills. I mean, we were working with a client for 8 months, so we were basically like their consultants. So, holding professional meetings, making sure they were running on time, covering the material we wanted to cover, and additionally in keeping them updated with our work, as well as following up. So when we needed questions answered, when we needed more materials for testing, making sure, we send an email, wait a day or two, follow up with that to make sure we kept the project moving along. Because, an 8-month project, there's a really, you need to provide a very quick turnaround time for a lot of this stuff. So we learned how to work around tight deadlines, as well as with following up with a variety of contacts at Queen's, as well as within PeakWorks.
Thank you, Queens.
Thank you.
Ready? Okay, we'll have our next team. McMaster, please. And this is Mohammed Azari, Mohammed Hussein, Amruddin Abdul Hadi, and Amrul Ishaq, and they're partnered with Advanced Solar Technologies. Anytime.
Good evening, ladies and gentlemen. Welcome to our presentation. My name is Mohammed Azhari, and to my left is Amirul Ishaq, Amruddin Abdul Hadi, and Muhammad Hussein. We are working on a product called Solar Skylight, and we are in collaboration with Advanced Solar Solutions Incorporation. So our motivation on working on this project is to overcome a common problem faced by the RV users, and that is the discomfort caused by the excessive natural light coming from the conventional skylight window with inconsistent intensity throughout the day. And we are required by our industry partner to optimize the performance of the product by fulfilling the two main criteria. And they are the consistency of light intensity as well as the maximization of light transmission for solar energy purposes. And for that, we have to find the optimum surface roughness of the prism window panel. Yeah. Here is our product prototype. And the structure is placed on top of the RV. And the aim is to get as much light as possible during the morning and evening, and a little bit lower light during the afternoon. The reason for that is because you know that the intensity of the sun during the afternoon is at the highest and the lowest during the evening and the morning. So by doing so, we will get pretty much consistent light intensity throughout the day in the RV. So the light that enters from the top, the light that enters from the top of the prism window will be deflected onto the solar panels onto 4 sides of the walls, and the electricity generated will be used to light up the LED during the night. So throughout the project, we work with various industry suppliers, and we maintain a direct connection with them. And working in a real environment, we realize the fact that our resources are very limited. So we have to carefully design the product and choose the best materials without compromising its performance. And we also have frequent meetings with our supervisors as well as technicians regarding the use of toxic chemicals in surface preparation of the prism window, as well as suitable testing methods. We first analyze the suitable materials to be used in the production of prism window panel, and then we conduct various testing mechanisms to test on the durability of the materials chosen. And then we use different techniques to prepare the samples, such as spray coating, film polishing, vapor polishing, etc. Then we design the method to find the exact value of the surface roughness of the prism. And finally, we conduct the experiment to test on the performance of all of them. And problems and challenges. One of the problems that we had was the preparation of various prism surface roughness, and we had a total of 12 different samples. And for some of them, we had to use the toxic chemicals, so we have to very carefully handle. And ample time was spent in total in preparing all the samples. And secondly is the surface roughness calibration. Due to its complex geometry and transparency, a special technique is designed to where a beam of laser is directed onto one of the prism and a pattern is deflected onto the wall where we calculate its area. And from there, we compare with the roughness value of a reference surface, and we can get the roughness values for all the samples. And this is very important because we need to observe the pattern of the performance of all the samples, whether it is optimal to increase or reduce the surface roughness. And another problem is the rainbow effect. The rainbow forms as the surface gets smoother, and this is very undesirable because we don't want to have a rainbow in the RV. And from all the solution that we have, we opt to use the diffuser film because it's very convenient to be used. And apart from diminishing the rainbow effect, it also increases the consistency of light intensity in the samples. And as a conclusion, the performance of the product increases as the surface roughness of the prism window gets smoother. And also, the product can also be used for other applications. And you can see that we have categorized the use of materials in other fields of application based on the experimental result that we have. The illumination for the acrylic and also suitable to be used in the supermarket, and the PVC can also be used in the classes. So we can use in multi applications in the real world.
Thank you, McMaster.
Thank you.
questions?
So from your client's perspective, what was the biggest success that came out of this project?
They actually start on this project by machining the prism window, and we'll create a very rough surface roughness of that. And we conduct the experiment to actually prove to them that when we get the surface roughness smoother, it will increase the performance, and we get that result. And we recommend to them to invest some money to opt for the industrial technique methods, such as injection molding, compression, and compression molding methods, which will produce a highly smooth surface roughness and increase the performance of the window. And it is also suitable for mass production. So if they are willing to market this product, that is very essential.
And what are their plans with the good ideas you've given them? What do they intend to do now?
We completely let them decide what they are going to do. We do our work because they had asked us to optimize the performance of this product, and we did all the experiment and we got the result, and we already present to them what is the outcomes. And so it's now depend on them to decide whether to continue on this product. And I think they actually market this product right now, and you can find the booth in this conference. Yeah.
Any further questions?
How did you choose this project?
Basically, our department have our industry partners to come to the class and present their ideas on what they're doing and what they want us to do. And we have to make a ranking on which project we are interested on. And from that, they assign us with this project. And so this is based on our preference. Yeah.
Thank you. Okay, next team we have is University of Toronto. And presenting we have Siri Nomenko with teammates Anthony McLeod and Daniel Fonseca. And they were partnered with Bombardier.
Good afternoon, everybody. My name is Sergey Nomenko. This is Anthony McLeod and Daniel Fonseca. We're an international team with collaboration with Peking University. Unfortunately, two team members couldn't be here. We're here to present you the vent dehumidification system for aircraft systems. And as you can see on the diagram, the arrow points to where the system would be located in the undercabin. So our client is Bombardier. It's a large aircraft, regional aircraft manufacturer, and the downstream manufacturing plant signature aircraft is the Dash 8 Q400 airplane. So our solution's lifetime benefit is estimated at $33,000 per airplane from the reduced maintenance, as well as the creation of jobs if implemented into mass production. So these airplanes are used by Porter Airlines extensively, and but they face a large problem. And what happens is, in between flights, the moist and warm air enters into the undercabin, and then it's trapped during the flights. Due to the elevation changes, there's a temperature gradient between the outside and the inside environment, which causes condensation to occur in the undercabin. This causes three main problems. The first one is the added weight from the water accumulating in the insulation. The second one is the possibility of corrosion on unwanted materials. And the third one is the safety concern from the failure of electrical components. So this being an aircraft design, we faced a lot of challenges and limitations. So we had to design a system that weighted under 20 pounds, cost less than $20,000. It must fit into the existing space and must not increase the maintenance periods. So how do we achieve this? Well, we knew we had to go about this by implementing a vapor compression cycle. As you could see on the screens, the psychrometric chart shows the steps 1 to 4, which is the process where we go about decreasing the water in the undercabin. So we knew in order to go from the theoretical to the prototype, we would need to have extensive interaction with our client. And we did this by having presentations and meetings to present all of our ideas and milestones. So for example, of an interaction, we started with a totally different idea with a Venturi valve, but this was quickly disregarded because of the fact that it added too much noise and it was too many vibrations. So our team then focused on establishing a common goal, which was increasing savings for our client. So our final solution was an iterative process, which went from the theoretical knowledge towards the final prototype, which you could see here. Anthony will point as I discuss the prototype. So the warm air enters into the first chamber where it passes over the evaporative coil and it collects at the bottom. Then once the threshold amount of water is collected, the solenoid opens and it lets the air go into the vent at the bottom level, which could be taken out and brought into the above cabin. Then the cooled and dry air is brought into the condenser chamber, which is used to decrease the temperature of the refrigerant. Then it leaves the system already dry and yeah. So our prototype advantages is that we utilize the 3-level design in which the top level contains all the electrical components and it's insulated from any moisture that could get into it. The second one takes care of the dehumidification, and the last one takes away transports the water away. So the other two main advantages of this design is the reusage of water. We don't have a storage tank, which eliminates the workers from having to physically go into the system and remove the water. We take the water away by the use of a solenoid valve. And the last one is we implemented a humidity and temperature sensor, which could be used to adjust the vent speed and the compressor speed accordingly. Our projected cost was $2,000 as opposed to the $20,000 constraint, and our weight is 15 pounds as opposed to the constraint of the 20 pounds, as well as using the plane's existing power. So some of the noteworthy achievements was that we placed 3rd place at the University of Toronto Design Showcase, as well as the Wallace G. Chalmers Award. And since the client liked the idea so much, we are going forward with patenting it and moving forward from there. So that concludes the presentation. I'll take any questions if you guys have them.
What was the biggest challenge about meeting their design constraints?
Well, since it's going in an aircraft, a lot of things have to be certified. So we did present to our client a number of designs, and they were rejected because they didn't meet air regulations, such as as Sergey mentioned, the Venturi valve was too noisy. So we eliminated that design, and we came up with a continuous flow of air within the heat exchanger instead of a sealed container. That was probably one of the biggest challenges faced from our client, was the design.
What happens to the water?
Pardon?
What happens to the water? You said it goes up to be reused in the cabin.
Right. So
should I be worried about what I'm getting in my water glass?
No, you're not going to be drinking the water. It's actually the water is reabsorbed into the air conditioning system, and that's sent to the main environmental control unit at the back of the plane, because all planes are equipped with an environmental control unit that has a dehumidifier. It's just that dehumidifier is used in the passenger cabin. So we're condensing the water, and that moisture is being just moved to the ECU, the environmental control unit.
Thank you.
Any other questions? Thank you, Toronto.
No problem.
Our next team is Western University. Presenting will be Rob Valco with his teammates Thomas Zolas, Arthur Gonzalez, Marco Furano, and Emily Keys, and their partner was the City of London.
Check. Hey, good afternoon, everyone. My name is Rob Volko, and on behalf of my team, I'm pleased to present our design for a new cable-stay pedestrian bridge over CN rail tracks in London, Ontario, for our client, the City of London. We sought to deliver a safe, serviceable, and sustainable design that improved pedestrian access to the downtown core and encouraged both long-term social and economic growth. The need for this crossing was put forward by the local residents and exceeds the goals of the London Transportation Master Plan. Before we begin, we'd like to acknowledge the Ontario Centre of Excellence for hosting this competition and this conference. And we'd like to acknowledge the contributions of our internal advisor at Western, Dr. Harmon, and our external industry advisor, Mr. Dwayne Buck of DC Buck Engineering. So today we will first highlight the design considerations and site selection for our bridge. Then we'll explain the technical, project planning, and management aspects. And we will conclude with some notable outcomes of the project. Throughout the presentation, our collaboration with the local community, advisors, and suppliers will be highlighted, illustrating how our team was able to deliver a pedestrian-friendly crossing for our client, the City of London. So in consultation with members of the Soho, or South of Horton Street community, shown here in London, it was determined that the ideal downtown crossing was at Talbot Street, based on its proximity to various downtown amenities. Although alternative crossings exist on neighboring streets, shown here and here, the community feels that these crossings are unsafe and uncomfortable for pedestrians due to poor lighting, narrow sidewalks, and proximity to heavy vehicle traffic. Talbot Street is therefore the ideal location. Shown here is a photo of the existing site. The structure was designed within the Talbot Street right-of-way to minimize impact on adjacent business operations and to minimize the cost to our client. Although this was very geometrically challenging, our design did not require the additional purchase of land and maintain access to private parking lots and CN Rail access gates. Once the design was completed, the proposed artist rendering looked like this. So our design is a single-span, cable-stay covered pedestrian bridge. Our bridge spans 25 meters and features symmetric reinforced concrete piers, complete with traction-bearing elevators, precast helical staircases, and a full curtain wall finish. Our enclosed segmented deck is supported by 16 galvanized duodeg bars, anchored into a reinforced concrete frame and supported by a square raft foundation. The simplistic elegance of a cable-stay bridge is both innovative and leading edge, yet stays well within contractor capabilities and the city's operational budget, both of which are essential for successful industry applications. So we'll now get into the project management and planning side of things. We primarily focused on safety, scheduling, and sequencing. So safety was of paramount importance to our team. After consulting a local architect, we opted for a 3.5 by 2.5 meter elevator in each pier that enables emergency stretcher access should pedestrians require medical assistance. We chose to outfit the entire structure with automated sprinklers and fire-rated magnetic controlled doors, as per industry convention. Our design also featured 2-meter wide staircases that permit two-way traffic and reduce the risk of bottlenecking during an emergency evacuation. These safety features were inspired by conversations with local subcontractors and suppliers, and will reduce maintenance costs, in particular eliminating the need for snow removal services. In terms of construction sequencing, our deck will be constructed in a series of 3 modules. 2 exterior modules are each supported by 8 cables, and the interior module will be dropped in place once the first 2 are erected. The deck slab and steel portal frames are placed as a finishing touch to provide framework for the curtain wall and roofing finishes. This type of construction sequencing was suggested by our internal advisor, as it minimizes temporary interruptions to CN Rail operations. A high-level construction schedule was created for the project, and we anticipate that it will take between 7 and 8 months to complete, with no permanent interruption to CN Rail or Greyhound. The concrete piers can be constructed simultaneously, which will provide the contractor with time and space savings. So with all that in mind, one of the most notable outcomes of our design was the emphasis on sustainability. Our pedestrian bridge intends to meet LEED certification by using recycled and local building materials, traction-bearing elevators, and passive solar venting. Traction-bearing elevators do not require a heated hoistway and avoid the use of hydraulic oils. This enabled a reduction in the energy requirement of our structure and eliminated the risk of oil leaching into the groundwater. To prevent the structure from acting like a greenhouse, passive solar venting with temperature-activated coupled louvers will be used. When the temperature is too high, louvers located at the top and bottom of each pier will automatically open and dissipate the heat through a natural airflow driven by a thermal gradient. Another notable outcome is a realistic cost estimate. The all-in price is just under $2 million, which is well below the $4 million anticipated by our client. In conclusion, our innovative design supports London's drive to become a great place to live, work, and play, and at Western we'd like to add in a safe, serviceable, and sustainable way.
Thank you, Western.
Is the city going to build it?
They have allocated a certain amount for infrastructure developments of their transportation master plan. The current focus is on the expansion of a highway overpass at the VMP Parkway, where they're expanding the 401 to 10 lanes. The community, the Soho community and the London Transportation Plan have both identified this crossing as being necessary and as being desired by the local residents. At this point, our design is finished. We have 300 or so pages of calculations to show for it, but it's out of our hands whether or not this will actually be constructed.
Could you just clarify for me, you talked about the elevator being the emergency access, but is that also going to make it handicap accessible?
It is. So one of the biggest constraints here was that we had a 9 meter by 9 meter area on the north side to work with. And in that small span, because we had to clear the elevator tracks by 7 meters, we had to essentially go up 9 meters in a 9 meter by 9 meter area. So the most reasonable solution for accessibility, which is something that both plans, the TMP and the SOHO plan, have outlined, was to include elevators. And the ones we picked were both, cost effective and very environmentally sustainable.
Can you tell us a little about the skill sets of the people on the team and how you work together?
Absolutely. So I took on the role of project lead. So I was supervising a lot of the design and planning of the project. I was the primary point of communication between all of our advisors and industry and with the rest of our team. Going down the line, Thomas was our geotechnical whiz. He designed the entire subsurface profile, working with very little data, and did an absolutely phenomenal job. Emily worked substantially on the reinforced concrete and the elevator aspect of it, which the suppliers were not easy to get in touch with, but again, she did a fantastic job. Marco was working on the deck. That was his baby throughout the whole year. He designed all the cable connections. He did everything with the HSS, with the construction sequencing. And Arthur was our AutoCAD whiz. He worked on everything exterior, so everything cable. He worked on the anchorage, and he ultimately supplied us with drawings that were, in our opinion, good enough to send to a contractor and essentially be ready to construct tomorrow.
Thank you.
Thank you, Western. And finally, we have the University of Waterloo. Presenting is Jay Hebert with his teammate Thomas Hudson, and they were partnered with Detour Gold Corporation. Anytime.
All right, hello, and thanks for your time. I'm Jay Hebert, and this is Thomas Hudson, and we were part of a team of 4 mechanical engineering students at the University of Waterloo. Our goal for the project was to develop a cable handling device that would be more efficient, cost-effective, and easier to use than existing solutions. And this would be achieved through reducing the number of required operators for the device, and also by increasing the existing equipment utilization. So the project started about a year ago when I was working on a co-op placement at Detour Gold. Detour is a large open pit mine about 750 kilometers north of here. It's got large electrically powered equipment. It's got rope shovels and drills, and these pieces of equipment have electrical cables that they drag around with them that connect them to the grid in order for them to operate. So what happens is these pieces of equipment move around the site fairly often, but they need supplemental equipment to move this cable around just to avoid damage to the cable. And it was at Detour that I noticed the issue that we needed to improve existing pieces of equipment that do this. And so with a few ideas in mind and consulting the mining operations team, I left the school, we assembled a team, and came up with a few concepts and put a proposal into Detour. They accepted, and so between Detour Gold, OCE, and the University of Waterloo, we gathered about $5,000 to build a scaled prototype and also do some testing. Sorry, I'll go back one step here. Building the prototype, we built it ourselves, except for a bit of welding. The University of Waterloo helped us out with that, with their own welders. And we also worked in part with Conestoga College. They were nice enough to supply material and man hours for building it themselves. In terms of industry engagement, we worked hand in hand with Ricky Boutsiet, who's the mine maintenance manager at Detour Gold. Ricky was our main contact throughout. We asked him for little questions here and there throughout, but mainly at 3 key points, which was conceptual design selection, preliminary design review, and final design review. So as I mentioned, we put together a few conceptual designs that we thought would be suitable, and we convened with Ricky and the team and decided on this telescopic boom design. After hours of design analysis and CAD design, we came up with a finalized prototype, which again we convened with the team and Ricky and determined that a better design would be a dual stage, which improved safety and also reduced maintenance. So in terms of the project management, we broke it down into 4 main components: fabrication, CAD design, design analysis, administration, and accounting. Each of these were all going in parallel, and so with the 4 team members, 1 person was assigned to each of these categories, and every week we'd have meetings to reconcile and make sure that we're all on the same schedule and moving forward. The last part of the project was about 2 months of testing, where we went through about 4 testing stages and 3 redesign cycles. You'll see here we had some we built it, borrowed a loader from the University of Waterloo, and we're able to actually do some real testing. Here you'll see it's not an actual cable, it's a piece of garden hose, so we put on weights to simulate the actual properties of the cable. We were able to successfully pick up the cable, and you see there it gets caught on little welds, so we've ground that down. But we were able to successfully pick it up without any excess manpower, translate the cable. Here you can see it's a simulated berm that you'd see at a mine site. So translate the cable away from the equipment, closer to the equipment. We're also able to successfully drop it off without any supplemental manpower. So where we're going with this now is within the next month or so, I'm going to propose the project to upper management. It's been approved within engineering, but we've got to go to the next step of management to make sure that they want to go ahead with this. Going ahead with this, we need to make sure we're going to get a proposal for testing. We'll implement any modifications to the design that we have already and test on the actual cable with the scale prototype. From there, we'll implement any observations we make from that and build a full scale and put it into operations. So, yeah, that's it. Any questions?
Thank you. Questions?
What was the basic problem you were trying to address here? Why did they need a new cable moving device?
So essentially, the existing solutions are cumbersome to use, they're costly, and they're very finicky. So they have a lot of hydraulic components, a lot of very specialized components. And so when they break for a long time, and they're hard to find parts for, and they're expensive to repair. This was meant for a very rough and rugged piece of equipment that you could leave right next to the piece of equipment that you can repair very quickly if it does get damaged, and it's not very finicky. You can throw this in the mud and it'll operate just as well.
Can I ask, Detour Gold is the mine?
Yes.
Right?
Yes.
So is it not true that all manufacturers of the equipment itself, so not the mine, the user of the equipment, but the manufacturers would find this ingenious?
Yes. So the initial intent, I have to agree with you there, but the initial intent for this project I saw was there was an issue in the process, an issue in the workplace. And so as an engineer, it was in my head to, okay, I have to fix this. It wasn't until about 4 months into the project that I saw the bigger picture. So, we're going to go ahead with Detour as a sponsor with this, and seeing where that goes. If they're with us, then we'll continue with them. It'll be good to have them on our side for a testing facility and more fun, to keep developing it. And if they don't want to go with us, then we've worked on other contacts that would have the capital, time, and resources to help us get to where we need to go. Yeah, money, yeah.
Yeah.
How much training is required to have this operational, such that somebody can understand how to do this and the operator can use it?
Yeah, so equipment operators they're fairly flexible guys. They're good at seeing physical things in their minds. And so what we saw from even our implementation, he was very quick to pick up on how it worked. So, the end goal is we want this cable in a different location. And so they're very good at using tools, whatever's available to them. Right now, whatever. So the answer is it's very short.
A quick question for you. So Jay, you've had an ongoing relationship with the company. That's something that your team members didn't have. I'm wondering how the rest of the team capitalized on that relationship. How is that managed?
Well, for one, right at the beginning of the project, Jay did a very good job of, he actually held basically a session or a little seminar on what's going on, who are we talking to, and he did this for us and our advisors at the school. So we got a really good grasp of what was going on and how everything works at the mine. And he also introduced us to Ricky. I mean, we didn't get to meet him in person, but we did get to talk to him. So we were very familiar with the main contact at the mine, and we were able to ask him the questions that we needed to. We didn't really have to always go through Jay. Thanks. All right, thanks.
Well, that concludes our Connections program for this year. And I just want to remind you that the awards luncheon is tomorrow at 12 noon. So I hope you'll all join us for the lunch and the awards for all of the competitions, including this one. I'd also like to thank the students for great competition, and you can see from the range of projects that all the students pretty much go through the same process in Connections, and different challenges pop up in different projects. So anyway, thank you. Thank you for great presentations. Thank you to our judges, Caroline Summers, Brian Armstrong, Lucy Keating, and Jenny Millinen, and hopefully you'll enjoy the rest of the conference. Thanks very much.